What's up everybody, welcome to another video. Hope you're ready to flex those brain muscles. In this video we're going to practice factoring quadratics where a does not equal 1. We're going to use the trial and error method. So this is sort of reverse foiling or unfoiling, right? So I really like this method because we're really using our understanding of these quadratic expressions and really getting to understand how this factoring process works and why it works. Okay, so we're going to use this method. I'm going to introduce it. We're going to go through these 6 examples. The video will be all time stamped up so you can skip around, and hopefully by the end of this video you're an expert at this trial and error method. So first let's relate this to a video I just made on factoring quadratics when a does equal 1. And I hope at this point you have this down. If you don't, I'll link that video up above. It should pop up. But we really relied on some key understandings of these types of expressions in order to factor these, right? So again, factoring, we want to write product of two binomials, and the first thing we relied on was the fact that both of these first terms are always x, right? We have an x and x. And the reason why this is the case is because when I FOIL this out, because again, that's what I want to do here is write two binomials multiplied together that equal this original thing. So I need to be able to FOIL this out and get this, which is kind of why we call it reverse foiling, because I'm reversing that process. Right? So again, the reason why we can place x and x here is because that is the only way to get our x squared term, is multiplying the two x terms. In other words, the result of the first step in FOIL, that f, right, gives us our x squared term. The second and third sort of patterns we notice were, we sort of use them together, right? The first is that, oh, these two things multiply together to be negative 15, because that's the only way to get a constant term from FOILing this out, is to multiply together two constant terms. So whatever these are, they multiply together to be 15, but they also add together to be positive 2, and that's because of our outer and inner terms, right? When we FOIL this out, we get x times some number plus x times some number, and we combine those like terms, and we're going to end up with 2 when we combine the like terms. Right? So using those together, what we're thinking about is two numbers that multiply together to be negative 15 but add together to be positive 2, and in this case that should be plus 5 minus 3, and we can double check that by FOILing this out. X squared minus 3x plus 5x minus 15, that does in fact work. So again, 3 key ideas that we're using to factor those when a equals 1. But now, what if we have something like this? 2x squared plus 7x. What if we get crazy and make a equal to 2? How does the game change? And it turns out we have some pretty similar ideas we can use, but it gets a little trickier. There's a couple of new challenges. Okay, the first is that we can't just write x and x, but we can still use the same idea, which is that, look, the only way to get an x squared term from FOILing this is by multiplying the two x terms, right? These two x terms, right, the first terms in the binomials, are always going to give us the x squared term. So whatever these are, they need to multiply together to be 2x squared, and since 2 is prime, we can actually just fill in 2x and x, right? We can go ahead and fill that in. The second similarity is with this plus 3. Again, from FOILing this out, we're always going to get our constant term by multiplying the two constants together, right? So it comes from that last step in FOIL, multiplying the two constants together. So what does that mean? Well, we either have a 3 here and a 1 here, and a 1 here or 3 here, right? Really, we have 2 choices. And maybe you're thinking, well, how come there's not 4 choices? Because technically negative 3 and negative 1 work. Well, think about negative 3 and negative 1 that's from our outer and inner steps, that's going to give us a negative coefficient for x, right? Because if I have negatives here and here, I'm going to end up with 2x times a negative number plus a negative number times x, and that would make this minus. So we can eliminate that. And now maybe you're thinking, well, what if we look for two numbers that add together to be 7? And what really messes that up, the reason why we can't use that here is because of this 2. This is really screwing us up, right? In this case, we had a nice little x and x, where our coefficients there were 1. And so when we combined our like terms, we always combined minus 3x plus 5x. They were always those two numbers that we multiply together, added together. In this case, one of them is going to be multiplied by 2, right? Whatever goes here, for example, if 3 goes here, now we're doing 2x times 3, and that's blowing up to 6x. Right? And so again, when we're looking at this, the main point I'm trying to make here is that when a is not equal to 1, we can't look at the 3 and say, oh, two numbers that multiply together to be 3 and add together to be 7. That no longer works. What does work, however, is our two first terms have to multiply together to be x squared. That does work, right? What else works is our two constant terms have to multiply together to be the constant term. And then as we notice, we can notice patterns related to the signs. That's going to be big. Like, oh, plus plus means we have to have plus plus here. That's the only way for this to work. So again, we have two combinations, which is plus 1 plus 3, or plus 3 plus 1. And the final key thing I want to point out is that those are two different things. Back here, if I replace this with minus 3 and this with plus 5, it's the exact same thing because both of the first terms are the same. In this case, the first terms are different. We have 2x and x. So 2x plus 3 times x plus 1 is different than 2x plus 1 times x plus 3. If you don't believe me, try it out. So let's see if this works. I just randomly put the 3 and the 1 in. Let's see, we get 2, first 2x squared plus 2x plus 3x. That's going to give us plus 5x, right? We want to get 7. So I think it's going to be the other one, plus 1 plus 3. Let's try it out. That's 2x squared plus 6x plus x. That's going to give us that plus 7x, right? So we can write all this out. We get 2x squared plus 6x plus x plus 3. And those middle terms combine. And that gives us 2x squared plus 7x plus 3. So hopefully that explanation for how this works makes sense. Hopefully you see the key ideas here. These two numbers always multiply together to be this number, right? I'll use purple here. These two numbers always multiply together to be our constant. And when a is not equal to 1, we don't necessarily have the two numbers that multiply together to be 3 but add together to be plus 7. We can't use that rule when a does not equal 1. We got to do other stuff. So those are the key challenges. Let's try some more examples moving forward. All right, so we got our first example. So again, we're going to go ahead and write our two sets of parentheses here. And what we're trying to do is rewrite this quadratic as the product of two binomials, right? So we want to set it up to where we can FOIL this out and get right back to where we started, right? Because that would mean they are equal. So let's think about how we can do that. Again, first main thing we're looking at is we want these first two numbers to multiply together to be 3x squared, right? Because we know that when we FOIL it out, that's the only way we can get 3x squared is if these two numbers multiply together to be 3x squared. So it's nice, since 3 is prime, we can literally just write 3x and x, right? We really have one choice at this point. So it's nice when the leading coefficient is prime. Additionally, 2 is also prime, right? Which is helpful because, again, we want these two constant terms to multiply together to be 2. However, one thing we have to consider is that, well, positive 2 is what we want them to multiply together to be. So really, we still have some choices here. I think we can eliminate this choice immediately, right? And I want y'all to see why and really understand why. How can we eliminate minus 1, minus 2 immediately without even trying it? Well, we can look at this plus here. How does this plus help us? Well, look, since this is positive, think about if we had the minus here, what would happen is this would be negative, this would be negative, we'd be adding together two negative x terms, and that would mean that this plus would have to be a minus. That would be the result, right? So that can't happen, so we know the only possibility is plus plus. Hopefully that's making sense, right? Plus plus here has to be plus plus here. So we either have 1 and 2 or 2 and 1. So let's first try 1 and 2. And the thing I want to point out for you to do this in a speedy way is that we know that our first and last, right? The first and the last, we know that that checks out. We know that 3x times x equals 3x squared because that's how we wrote 3x and x here, right? And we know that 1 times 2 is 2 because that's how we got 1 and 2. So really when we're checking to see if stuff works, we only need to check the outer and inner and see if those add together to be plus 5x. So that's what I'm going to do. Outer, that's 5x, plus x, that's 6x. So that doesn't work. So 2 and 1 should do it. But let me double check. 3x, 2x, those add together to be 5x, so we are good and we can fully FOIL this out. I won't do this very often. Let's see, 3x squared plus 3x plus 2x plus 2. And again, these two outer and inner terms combine to be 3x squared. And this is always a way you can check your work to see if your factoring is correct. If you factor correctly, you should be able to distribute, FOIL it out, and get exactly where you started. So we are good in this case. So let's try the next example here. So the first thing I noticed, and there's a reason I put this example here, is that all of the coefficients here, right, the 4, 10, and this constant term 6 are all even. That means they share a common factor. We can factor out at least a 2. And in fact, I think 2 is greatest common factor in this case. So if we factor out a 2, we're left with 2x squared plus 5x plus 3. So this is sort of my example, and I put this toward the beginning to just remind you we should still be checking for common factors before we try factoring, right? Because this now is going to make our life easier. Before we had 4x squared, now we have 2x squared. And again, 2 is prime, so we know from here there is only one possibility, which is that one of these starts with 2x and the other starts with an x, right? 3 is also prime, so what are our choices here? Well, 1 and 3, or -1 and -3, but for the same reason as the last example, we can eliminate -1, -3, right? Because this here has to be positive. So we know our only choices are 1 and 3, so either +1 +3. We can try this out. Let's see, that gives us 6x plus 1, that's 7x. Okay, that's not going to work. So instead we will do +3 plus 1. That gives us 2x plus 3x. That is 5x, which is exactly what we want it to equal here. So this is going to check out. This is the fully factored form. These are all equal to each other. Hopefully that makes sense. So again, moral of the story, always check for a common factor. First thing you should do. It's going to make your life easier if you can find one and pull it out. Awesome. Next example here. All right, I don't see a common factor, but what I see is that we have a 2x squared as our leading term. And again, 2 is prime. We like that because I can immediately write this out, right? Those two first terms have to multiply together to be 2x squared. So we have to have 2x and x. All right, now it's a little tricky because we're not dealing with a prime number here. We have some choices. So what are our choices here? For 15, we have 1 and 15. We have 3 and 5. And then we also have negatives. -1, -15, and -3, -5. So this is a different situation because now we have -13x. And then at the end we have +15. So this actually gives us a lot of information, this -13x, because it's telling me when I multiply the outer and inner together and add those together, I get something that's negative. This tells me that this has to be minus and minus, right? Think about it. X is positive, 2x is positive, right? So if I have to be able to multiply these two things together, and add them together and get something negative, then at least one of them has to be negative, right? But since we have a plus here, we know that they both have to be negative in order to multiply together to be positive. Hopefully that explanation makes sense. So basically the moral of this story here is we can eliminate these here. We know it has to either be -1, -15, or -3, -5. So we can go through and check some of these. Let's try -5, -3. And again, we're just trying the outer and inner and seeing if they add together to be -13x. So our outer here is -6x, -5x, that's -11x. All right, so that didn't quite work. So let me try -3, -5. What is our outer and inner? That's -10x, -3x. That does give me -13x. So I found it pretty quickly. That checks out. When we FOIL it out, we get back to where we started. Hopefully that process made sense. So again, we've sort of come up with a generalization here, which is that when we have this plus plus, then we're going to have plus plus here. And when we have this minus plus, we're going to have minus minus here. So let's keep trying this. Now we see that minus plus again, right? So first let's start, but this is kind of tricky. Okay, why is this trickier? 8, right? So now we're not dealing with a prime number. We have some choices here, right? Let's see, is there a common factor? No. Okay, so that sucks. So what are our choices? 8x and x. That's one of them. Those multiply together to give us 8x squared. What else? 4x and 2x. Awesome. All right, so we have two different choices for pairs of first terms. This is the first time we've seen this so far, so it makes it a little tricky because now we're dealing with some different possibilities here. Luckily, the number at the end, plus 3, is prime, and since this is negative, we've used our sort of pattern that we notice, which is that, well, we can't have plus 1 plus 3. It has to be minus 1 minus 3 because that's the only way to make this term negative. So we can eliminate plus 1 plus 3. We can put minuses here. And now let's see, how many situations do we have to check? I think just 4 total because we have 1 and 3 here. We have 3 and 1 here. And then we have 1 and 3 here. And 3 and 1 here. So just 4 different possibilities to check. So let's try 1 and 3 up here. And again, we're just looking quickly at the outer and inner terms. What are they added together? So outer, I can already tell it's going to be way too big, right? Do y'all see how I don't need to continue? Minus 24x, yeah, we can just scrap it there. I guess technically way too small. Big in the negative direction, right? You'll get what I'm saying. So what is this? Minus 8x minus 3x. So that's closer, minus 11x, but still not it. Okay, so we've eliminated both options there. And so what do we have here? Minus 1, minus 3. Is this going to work? Let's see. Outer. That's minus 12x minus 2x. Yep, this is it. Hopefully it makes sense how I'm narrowing down these choices and using this trial and error method. So this is the first example we've seen where c is negative. So let's see how that changes things. So again, we can start with our parentheses here. And since I have this nice prime 7 as the leading coefficient, I can go ahead and fill in 7x and x. Those are the only two possibilities. And now for these constant terms inside our binomials, I need them to multiply together to be negative 15. So that means we can have 1 and negative 15. We could have negative 1 and 15. We could have, let's see, 3 and negative 5. And we could have negative 3 and positive 5. So here's a spoiler. This plus 32x, unlike the previous examples where c was positive and the sign of this b term, this x term, right, gave away whether we had plus plus or minus minus. In these examples, it doesn't, right? You have cases where this is negative, this is positive, and you have cases where like the negative is the bigger absolute value than the positive and vice versa, right? In other words, there's no generalizations we can make to all examples here because there are a bunch of counterexamples and weird stuff that happens when you start multiplying out. So really the best way to continue, in my opinion, what I do is start checking numbers, and I like to just start with the numbers and then play around with the sign, right? What does plus minus do? What does minus plus do? And as you get good at this, you're going to be able to check this pretty quickly and even in your head, right? Because I can already tell when I put the 15 here, this is so absurd. 7 times 15, that's 105. That's too big. It doesn't, plus or minus, none of that really matters. I just know 105 like is not going to work. It's not going to get me to 32 in this situation. So I can just get rid of that. 15 cannot go here, but maybe 1 goes here and 15 goes here, right? And here's again what I think about outer and inner. That's 7x and 15x. So our two options are minus 7x plus 15x or 7x minus 15x. And here's what I want y'all to notice about the relationship between these two is that this gives us 8x and this gives us negative 8x, and that's always a pattern, right? So we're thinking about, can we use 7 and 15 together, one being negative and one being positive, to get 32? And in this case, the answer is no, right? So that's, again, once you start doing this in your head, that's how you're going to think about it, is you're just going to say, oh, 7 and 15. Can I either subtract 15 minus 7 or 7 minus 15 to get b, which is 32 in this case? In this case, we cannot. So 15 and 1 are gone from existence. We are done with them. We're over it. They are dead to us. Let's try 3 and negative 5, or right, let's just try 3 and 5. So I'm going to put 5 here, 3 here. All right, what does this do? And again, this is how I want you to think about it in your head. 21 and 5. Can we do 21 minus 5 or 5 minus 21? Will that get us to 32? And the answer is no, that's not going to work, right? 21x minus 5x, that's what, 16x, and the other way around is negative 16. Not going to work. So maybe we try the 3 here and the 5 here. And again, notice the two numbers we get, 35, 3. We should already be making a connection between 35 and 3 to 32. Be like, oh, wait a minute, 35 minus 3 equals 32, right? And in that case, in this case, that's exactly right. That's what we need to do, right? So this 7x times 5 needs to be positive because we want positive 35x, and we want to subtract 3x from that, so this needs to be minus 3. And so these are the trickier examples where we have the minus here, right? Really just examples where we have the minus here. It doesn't matter whether this is plus or minus. The minus being here makes it tricky because then we have to think about that stuff. Hopefully this process makes sense though. We're going to try another example. So again, similar idea, but this time even harder because now the leading coefficient's not prime. This is a bummer. So we got to write out 10x and 1x, or just x. And then we got to write out 5x and 2x, because now there's two possibilities. And then we have negative 12, which also has a bunch of factors, right? We could have 1 and minus 12. We could have minus 1 and plus 12. We could have what else? Plus 3 and minus 4. And we can have minus 3 and positive 4. And now we got to start trying numbers in here, right? 1 and 12. I already know this is going to be ridiculous. This is 120, right? That's not going to work. What about 12 and 1? Is this going to work? Well, this is 10 and 12. I don't think I can do 12 minus 10 or 10 minus 12 to get 7. Remember, that's how I'm thinking about this. We have a negative and a positive, right? Let's see, so are 1 and 12 out? At least from this case they are. So we'll ditch 1 and 12. We'll try 3 and 4 up here, but I think the problem may be with this 10 and this x. It may just be this and it's not going to work. So let's try 3 and 4. 40. 3. No, that can't give me 7. Yeah, really the problem is this 10, because no matter what number I put here, when I do this outer, it's going to just blow up, be way too big. And so really it's this that's the issue. It's the 10x and the x, right? So let's get rid of that. All right, what about down here? Can I start doing stuff? Can I put 1 and 12 here? Nope, 60 is too big, right? That's going to be way too big. And I think 24 will as well, right? Because this is going to give me 5 and 24. Can I subtract one from the other to get 7? No. All right, let's see. What about 4 and 3? Here's a pro tip for why we know 4 can't go here, whether it's positive or negative. And we actually know that just by looking at this 2x. This is actually kind of a cool trick. 4 can't go here because if I put 4 here, then I'd be able to factor out a 2 from this binomial, right? They both have a common factor of 2, so I'd be able to do this and write it as like x, da-da-da stuff. The point is that once I FOILed this entire thing out, right, and distributed and expanded it and got back to something like this, it would have a common factor of 2 in every single term, right? Because this has factor of 2 in it. And my original, in this case, does not have a common factor of 2 in every term. So we know we can't have a situation like this where there are 2 common factors in a binomial. And in general, we know this is the case as long as we've taken out any common factors already, right? We can just eliminate there being common factors inside a binomial. So the 4 can't go there. All right, what does this give us? All right, 20, no, that's 15. 15 and 8. 15 and 8. All right, I think this is going to work. So what do we need here? 15 and 8. So our choices are, right, we could have a plus here, and that would give us plus 15x minus 8x, or we could have minus 15x plus 8x. Hopefully it's clear which one we want, right? We want plus 15x minus 8x because that's going to give us plus 7x. So we can distribute this out. 10x squared plus 15x minus 8x minus 12. That equals 10x squared plus 7x minus 12. And this does, in fact, work. Awesome. Hopefully that process made sense. Hopefully you are seeing the method to my madness for how I approach these trial and error style. All right, so with this example, I think I see another common factor. Is it 3? Can I take a 3 out of each of these terms? Let's see, I'd be left with 2x squared here, 7x here, and minus 15. Okay, do y'all see why this is so helpful? Because if I kept it as 6x squared, now I'm having to check 6x and x, and 3x and 2x, all those possibilities. Now look what I have. I just have a 2x squared inside these parentheses. What that means is that I can keep 3 chilling out here, and now I can automatically write 2x and x, right? So this definitely makes our lives easier. Got to look for common factors always, okay? So let's write out minus 15. This is becoming familiar, right? 1 times negative 15, negative 1 times 15. What else? 3 and 5. Sorry, 3 and negative 5 technically, and negative 3 and positive 5. So let's start trying numbers, right? I'm going to use purple as sort of my test color and do stuff like this, 1 and 15. 30x, x, can't subtract those and get negative 7x, so we're done. See how quick this goes once you get it down? Try the 15 there and the 1 there. 2x, 15x. We cannot subtract those and get minus 6x, so now we just literally went through half of our possibilities. Pretty quick, right? 3 and 5. Let's see. 10x, 3x. We can subtract those and get negative 7x. So which one has to be negative, which has to be positive? Well, the 5 has to be negative because we want this to be minus 10x plus 3x, because that's what gives us negative 7x. So we need to get minus 10x, which we get from there, and then plus 3x, which we do in fact get from there. Okay, so this is the fully factored form. 3 times 2x plus 3 times x minus 5. Hopefully that process made sense. So again, when we have the negative here, a little bit different than when we had a positive, and we could just determine whether they were both positive or both negative. Here we kind of got to do some experimenting and make sure you're writing stuff out. And again, best way to probably do it, especially in the very beginning, is just distribute all this back out and make sure you get to this, right? Awesome. I think there's just one more example. Yeah, let's check this one out, because this is a weird one. I wanted to make sure I put one like it because we have that negative out in front. So one thing you may try to do is like, oh, well, I have 2 choices, negative 6x, and yeah, we don't want to do that. I don't like that. To me, it's confusing. What I do is I just factor out the negative out in front and do everything else, like proceed normally with everything else, right? And so I can take out the negative, and I just have to make sure, okay, when I distribute this back in, do I get what I started with? And I do, right? And now we can just factor as normal. Again, this is how I like to do it. Other people may just continue with the negative. I think it tends to be a bad idea. And so we have options here. 6x and x, or 3x and 2x. It's one of those examples where we have choice, different options. All right, this 15 is just getting I didn't realize how many minus 15s I had in this video. Oh well. You should have the factors of 15 like very down at this point. All right, minus 3, positive 5. Cool, we got lots of different choices. We got different stuff going on. We want to try stuff out. I'll use my test purple color. I'll start with the 6x and the x up here. 1 and 15. Is this going to work? And again, what I want these to add together to is minus x. I'm focusing on that. Minus x, right? All right, let's see. Can I get it? Nope, the number's going to be massive. There's just no way. There's just no way. So again, minus x is what I'm focusing on. So 1 and 15. Will that work? Let's see. 6, 15. Nope. All right, so I think I just eliminated that. So now I just try 3 and 5 and 5 and 3. So let's see. 30. Yeah, that's not going to work. I think we probably could have, like, intuitively, once you get intuition for this, 18, 5, that's not going to work. Like, what I would have done if I weren't making a video and kind of going through everything is gone straight to this first. Just based on this being plus x, being a number that's close to 0, I'm thinking that these are going to also be close together, right? Since I'm making the video, I'm kind of going through it all, but as you gain intuition, again, that's probably something you'll do. Go straight to these. Let's try it. And I'd probably go straight to these as well. Let's go straight to 3 and 5. Let's use our test color purple. Test color purple. Let's see. 9, 10. Boom. See, my first guess, when I followed my intuition and was like, I feel like this is it. It was my first guess, right? And that's what's going to start happening as you get better at this. So let's see. We want to make this negative x. Do y'all see? Hopefully y'all see how I'm concluding that this is going to work, because we have a 9x and a 10x, and I can combine those to be negative x. I need to take away 10 and then add 9, right? And that's going to give me the negative x. So how do I take away 10 and add 9? Well, the minus needs to be here with the 5, and the plus needs to be here. Now let's go back. I'll use blue to check. 3x times 3, that's plus 9x, minus 5 times 2, that's minus 10x. So we have plus 9x minus 10x, which does give us the negative x. These two numbers do multiply to negative 15. We can go back, factor, or FOIL it all out, get right exactly back where we started. Hopefully this video helped. Hopefully it made sense. Hopefully you somewhat like the trial and error or guess and check method. I find it sometimes fun. It's like a little puzzle trying to figure out what goes in here, but hopefully you learned something. Leave any comments below, questions I'll try to answer. Like the video and keep flexing those brain muscles. I'll see y'all next time.